Hello, this is Mr. Huber. In this lesson, we're going to look at logarithmic functions and how they're related to exponential functions. Logarithms are written as you see here, okay, where there'd be numbers where the b and the y are typically. Okay, and the way we'd read this is log base b of y. Log is the abbreviation for logarithm. Logarithm's the name of the function. Okay, the base of b, and those could be different numbers. We'll see some examples down here when we get to those. Okay. Log base b of y equaling some number. Again, we could have numbers in there, as we'll see down here. A logarithm is defined as being written like this only if those same bx and y can be written in this exponential form. So you're going to find that this base, the base of the logarithm, is the base of the exponential. And then whatever you're taking the logarithm of is what that exponential is equal to with base power x. Okay, so we can rewrite logarithms as exponentials, and we can write the other way as well, which we'll see. And again, remember how this would be written in red: log base b of y equals x. So down here, we'd write this as log base 3 of 81 equals 4. And we're going to practice writing these logarithms as exponentials. So we're going to take the logarithmic form, we see right here and here, and we're going to return this into an exponential form. So again, the b to the x. b, the base is 3. So we're going to have base 3 to the x, in this case is 4, equals what we were taking the logarithm of, which is the 81. So again, base 3 to the 4th power equals what the logarithm was of originally. We go over to the next example, and we have base 7 to the 1st equals 7. Again, these make sense. If you go back and look at these, if you take 3 to the 4th power, you're going to get 81. If you take 7 to the 1st power, you're going to get 7. And one thing you'll find is whenever these two numbers are the same, it will always equal 1. Because you're going to have a number to the 1st power will equal itself. Okay, so if you see log base 8 of 8, it equals 1 every time. Right? When these two numbers are the same, when the b and y, if you will, here are the same, it will always equal 1. Log base 7 of 7 is going to equal 1. Log base 8 of 8 is going to equal 1. So just something to keep in mind. Right. Now let's write the exponentials as logarithms. So we're going to write this in logarithmic form. So we can take this first example and log. Now what's our base? The base here in the exponential is 9. So the base of our logarithm is also going to be 9 of 81 equals 2. Right? Again, you'll notice up here, the base to some power, that power then is what the logarithm is equal to. This power is what the logarithm is equal to. With a base of 9, and then we're taking the logarithm of 81. So in the next example, we'd have log base 5 of 625 equals that exponential part, the power that we had in this exponential, 4. So the big thing to look for is the base. Okay, base 3, base 3. Base 7, base 7. Base 9, base 9. Base is 5, the base is 5. Okay? And then the exponent is what the logarithm is equal to. The exponent is what the logarithm is equal to. The exponent is what the logarithm is equal to. Right, so get used to practicing that. We'll see where it can be important to write things between logarithm and exponential form. Okay, right now we just want to make sure we know how to do that before we see how we can apply it a little bit more. All right, a little faithful diversion here. What is the oldest U.S. national park? The oldest national park in the United States is actually believed to be the oldest national park in the world as well. Maybe these pictures, they aren't clues or not. Faithful diversion was a little bit of a tip. This is Old Faithful here, which is located in Yellowstone National Park. Old Faithful, one of the more famous features at Yellowstone. It was established as a U.S. national park in 1872 by President Grant. and again, believed to be the oldest national park and first national park in the world, definitely the first in the United States. And Old Faithful, again, a popular feature and destination for people going to see it. It erupts everywhere from about 45 minutes to 2 hours between eruptions, and it can be predicted down to the minute. It's pretty amazing how accurately they can predict when it's going to erupt. And do so. That's why it's called Old Faithful, because it faithfully erupts as can be predicted based on their scientific observations and different things going on. Okay, bison, other geothermal features in Yellowstone make it a pretty varied national park. A lot to do and see there. A lot of different animals and natural scenes to check out. So I'd suggest going if you haven't been there before. It's a pretty amazing spot to be. All right, let's see how we can use writing logarithms and exponentials with one another to be able to evaluate them. Okay, if we see log base 2 of 32, for instance, how do we know what that would be equal to? Okay, without using a calculator. And we're going to talk too as well about how if you put log in your calculator, it doesn't know what the base is. So we're going to talk about that in a second. So we wouldn't even be able to necessarily put this in the calculator maybe. So we know that this equals something. What is that something? Well, we call it x. So now if I have an equation, now I can write this as an exponential, right? I can take this base 2 to the x power equals 32. And I could figure out what exponent 2 would have to be the 32nd power, right? So 2 to what power would be equal to 32? The 5th power. So in this case, equals 5. So log base 2 of 32 equals 5. That'll be our answer. The next example, we've got 36 to the x power equals 6. So how can you take 36 to some power and get a smaller number? Keep in mind we could be taking a square root of 36, which we need to know what that is as a power, right? That's x to the, 36 to the 1/2 power, right? 1/2 power is the same as a square root. So keep that in mind. And the square root of 36 means the power would be 1/2. And then in this next example, we'd have 1/4 to the x power equals 64. So how can I multiply 1/4 by itself and get 64? Well, if x is a negative exponent, that would bring the 4 up to the numerator. Remember, we'd write it as a reciprocal. So 4 to the 3rd power is 64. So in this case, we'd have 1/4 to the negative 3rd power would equal 64. Because 1/4 to the negative 3rd power is the same as 4 to the 3rd, which would be 64. So this would be equal to -3. So keep in mind things we can do with fractional exponents, what we can do with negative exponents. We want to keep those in mind and know that we can take a logarithm, write it as an exponential to evaluate what that logarithm is equal to. We'll be practicing that as well. The last thing I want to talk about is what I mentioned with the base. Okay? Your calculator automatically reads logarithm as a base 10. It's called the common logarithm. Okay? So common logarithm is base 10. And if you see log written without a base, it's assumed to be a base 10. So you see right here, log 15 would be assumed to be a base 10. And we're trying to figure out how could I evaluate that? How would I know what log base 10 of 15 is? Because now I'd be trying to think about, well, that's 10 to some power equals 15. I don't know what power I'd have to take 10 to get equal to 15. So if you have base 10, you can actually put that in your calculator. If you go to your calculator and just put log 15 and hit enter, the log button's next to the 7 on those TI-84s we usually use. So you see a button there that says log. If you just push that, and then you type in the 15 after logarithm, it'll give you a little parenthesis there. That's good because you want to know what you're taking the logarithm of. And you hit enter, you're going to get that it would be, this would be equal to 1.17609, or it keeps going for, a few decimal places your calculator screen can read. Okay, so depending on how many decimal places we're going to go to, but you can evaluate log base 10 on the calculator. And again, if there's no base written, we assume that it's a base of 10.